Hello and welcome to another episode of the BetaKit podcast. I am Douglas Soltys, editor-in-chief of BetaKit, along my close personal podcast brethren, Rarb Kennedy. We are coming at you live from the Elevate Tech Festival. And today we are talking with someone that if you are a regular BetaKit reader, you might have heard about, company Xatoms. They've won a lot of awards earlier in this year. They're doing some
cool shit.
Yeah, exciting sciencey stuff. And we have with us today Diana Virgovicova, who is the CEO of Xatoms. Thank you for joining us.
Thank you so much.
We basically just like ripped you off stage because you were pitching, and then we brought you down into the basement to podcast with us. So
we don't give money at the end of this.
Yeah, unfortunately, you will not get money from this, but it might aid your chances pitching. That's not true. That's not true at all. Okay. So I think when we were looking through the people that we could potentially speak to at Elevate, there's like, you've got like
Kara Swisher.
You got Kara Swisher.
Whatever.
You got Director X. You got all these people, and we're like, actually, we want to talk to Xatoms because I think what you're doing with your company is both very, very interesting, and your personal journey is. I don't want to say incredible because I maybe hyping up the podcast a little bit too much, but it's certainly unique here in Canada. Do you want to maybe just at a high level explain what Xatom does and then how you got into the process and the science of like water purification? Maybe that's the best place for the uninitiated to figure this out, and then we can kind of dig into the sciencey bits.
Yeah, thank you so much. So this is my first podcast, I think, for discovery of new materials, drugs. And we are using this specific field called quantum chemistry. So quantum chemistry allows us to discover new materials without the necessity of being in lab, spending long hours in lab, but we can discover them by using simply computer and software. So we can see how the materials will react in different types of environments before we actually synthesize them and manufacture them. So that's why we use quantum chemistry to speed up the material discovery process. And with quantum chemistry, we can understand atoms and molecules at a fundamental level that enables us to make new discoveries.
Now, is the ease there like the scale at which you can do that work, or is it just like it's way cheaper than having like lab access and futzing around with chemicals? Is this like a new approach to doing sciencey stuff? Or was it just the most accessible to you given like the hard costs of labs or that kind of work?
It's both, but mainly you can discover materials faster. So last year, Microsoft released their Quantum Azure credits that enable researchers, scientists to discover materials. And they proved that with the quantum approach, they were able to compress 250 years of chemistry into 20 years. So basically, it's with quantum we will be able to discover materials much faster, and it will go beyond our imagination. The structures that we will be discovering, it's something we would not be able to discover in a lab.
What is the so it's about water purification, right? Like ultimately, it's about water purification. Most people, when they think of water purification, they think I'll get a filter and put whatever. Why you're like, you know what I'll do? I'll use a quantum computer to create new substances that don't exist. This is the approach to do it. Why is this the path that you chose to do to solve that problem?
Because current filtration solutions are unable to eliminate forever chemicals, for example.
Right.
Some specific viruses, some dyes, some pharmaceuticals in water. Even though it's not a huge amount at once when you drink it, but when you drink it over years, it can make you sick.
Yes.
Depending on which part of the world you live in.
But do you like, just my nerd question
please
is,
do.
when you create new things and that haven't existed before, there are methods of testing to make sure those things don't have weird side effects. Like it's not a drug, I understand that, but we are now understanding the effects of plastic 50 years into having plastics around. Can you have a sense of what the impact of using this technology and cleaning water is? Like, can you see if there's any residual stuff as a result of it?
Yeah, well, the person doesn't come into contact with the powder. The powder is actually transferred to a coating, and the coating is on the surface of the filter.
Oh, I see, okay.
Yeah, okay. So this is maybe a good prompt to get back into. Like, I think we want you to explain how this works. I also want to, I think you said you discovered 8 different molecules?
Materials.
Materials. I want to get into that, but even you were, I think you were alluding to something up off the top, following Rob's question of like, why are you working on this? Maybe where is there a need for better water purification? Can you kind of tie that to like your personal story and kind of discovering why this is important? Because I think, as we noted in a great feature that you can read on BetaKit.com, written by Isabel Kirkwood, you got involved in this stuff at like the age of 14. So this has been like pretty early on in your life as a mission or a journey. Like how did that start, and how does it connect to maybe some of the technical solutions that we were just starting to dig into?
Okay, so I can explain how it all started. So when I was 14, my mom and I went backpacking Asia, and that's when I for the first time ever saw pollution, black rivers. Especially what motivated me was that young girls who were my age were using this water during their periods, which was constantly making them sick. And so I decided I wanted to do something about this. And I always wanted to be an engineer and scientist. So when I came back to my home country, Slovakia, I contacted a professor at a local university who was working in the space of water and quantum. And that's when I got introduced to the entire field. And then I took a little bit independent approach, and I started looking at the quantum software. I started modeling new materials with that, or new molecules, and just
as
playing.
One does. You just pulled up a
just
quantum
playing
computer.
it out.
You started like, let me build some. Yeah, okay. Makes
So
sense.
it was a normal laptop, normal computer, but I was using a quantum software. Yes.
It's a really big laptop, yeah.
And then I got a full scholarship to study in high school in the UK, and that's when I really started working more on this and became more serious about this. And I heard about the concept called photocatalysts. So photocatalysts are materials which, when exposed to radiation, can eliminate pollutants in water.
Gotcha. So like instead of like when you're going camping, dropping the little packet in, shaking it, and then
you
like
expose it to
regretting.
sun, yes.
Yeah.
Mhm.
Gotcha.
But what I heard at that time was that the photocatalysts that currently are being used, it's not possible to commercialize them because they require UV radiation, meaning we need a UV reactor for them to work. So I decided that I wanted to find photocatalyst which is able to eliminate pollutants in visible light spectrum. So we simply need a sunlight. And so when I was 17, I used this software to discover a new type of material which would be able to clean water when exposed to visible light. So then I represented England at the Stockholm Junior Water Prize, where I won this world's most prestigious water award from the Swedish royal family, and that brought me to Canada on a full scholarship to study computer engineering at U of T. And here I decided that I wanted to discover more materials because this one material was able to eliminate specific type of a contaminant. It was E. coli, but we wanted to discover more. We wanted to go after bacteria, viruses, as well as agricultural pesticides. And then I realized that we can connect AI and quantum chemistry to speed up the process, and we can have more materials, and we can have a very wide range of materials.
Okay, you now you're adding AI to the quantum, and it's gonna hurt my head. I want to get to that in a second to have you like showcase how that works together. But just noting here that you got the Lester B. Pearson International Scholarship. You also got a Cansbridge Fellowship, which is how you met all your other co-founders as well. So you've had a bit of like, let's say, the idea of like pulling up the quantum laptop was a little bit accessible to you through these channels, right? This wasn't
Go to the Apple Store and
like you weren't doing this on your iPad or something.
No, we are not using quantum computer. We are using quantum chemistry. And that's a software that is we're using the HSPC clusters. So I'm bringing more words into
No,
this.
it's great. I might be scared. I think Rob is like excited by learning about this.
It's a big company. I know what you're talking about.
Yeah. Okay. So then can you explain how that intersects with the AI component then?
So we don't use quantum computers, but the quantum chemistry, we are using quantum algorithms. So we are using software which is based on quantum algorithms. And AI helps us to analyze large molecular data sets initially. And then with the quantum, we simulate the... So we have thousands of chemical research papers where photocatalysts are mentioned. So we analyze them with AI. We set our variables to be specific chemical bonds, chemical structures, and then we can see which out of these photocatalysts mentioned has opportunity to eliminate pollutants in the visible light spectrum. And then once we have these candidates, we then apply quantum chemistry to create the new materials from these candidates.
Your data set is the published knowledge of anything in your space, and then you're narrowing the fields down and then doing the quantum chemistry thing to see if that's going to yield results, basically.
Exactly.
Okay. Is that a because you were talking about the other ways that these types of purifiers work, and you were noting like specific things that they can't account for that you're trying to solve for. Was that limitation previously just not having broad access to like AI or quantum chemistry?
Exactly.
Was it just previously like, hey, we've discovered this thing, it seems to work, we rubbed it on ourselves and like the test was a pass? Like, is this a little bit of a function of not only your like personal interest in this, but like the timing at which it's a really good time to look at like the science and produce something better?
Yeah, for sure. I think we are at the beginning of the quantum revolution, and we are leveraging that, and we know its potential before many other companies understand that. And I think that's just helping us to discover materials faster, because current scientists and researchers, they usually synthesize the material in a lab, and they're going based on hopefully thinking that they will discover something with the synthesis techniques, but they don't have a already set structure discovered by computer, and they don't, because with our, we can test the material before we synthesize it in different types of environments and understand how it will react. So then we eliminate candidates that are not going to be effective in purifying water. So that just definitely saves us a lot of time, and then we can just focus on the candidates that we know that are going to be able to eliminate the pollutants.
So you're still in the R&D phase. Despite being the belle of the ball, you're still in the R&D phase of creating this stuff. I think you have a sample that you want to show us. Is that right?
Yes.
So what is that? So we're looking at a vial. It's full of white powder for those that are listening.
Yes.
It tastes like chicken.
Very
I don't
specific
know why,
white powder.
But, and what does the powder do?
So this has no taste.
Okay, then I have problems. I need to see a doctor.
We're going to need you to come back on the podcast when it does taste like chicken, because that's very important to us. No, but please continue.
So this is the powder that we discover with using the software. And this specific powder can eliminate E. coli in 30 minutes. And the powder...
You don't sprinkle the powder in the water.
No, the powder actually inside is coated on a surface. So it's not like...
Okay, it's not loose.
Yeah.
It's like the whole, circumference of the bottle is filled with powder.
You can see the coating.
Yeah. Yes.
Yeah. So it's coated around the surface, and that's how it's going to work, like in the tubes.
So you pour dirty water into that as is,
exactly.
And it will dissolve the powder, and it'll turn into clean water.
No, it's a coat. So this coating lasts for one entire year.
Oh, I see. So it doesn't come off. The
it doesn't
reaction
come
happens.
off.
You pour the water back out. It's clean.
Exactly.
How long does that take to turn into clean water? It's a vial that looks like a puffer. If you have asthma, so it's slightly bigger than a puffer.
Yeah.
I guess. How long would that take?
To be safe, it's up to 30 minutes.
30 minutes.
Okay.
3 seconds is what you
said. So then by way of comparison, like just having used like similar solutions before, it's usually like you get one of those like little wet napkin pack size things, drop it into a container of maybe like 1 liter, and you're having to like constantly reuse that. So not only are you attacking a broader set of like contaminants that might be a problem, it's also that's functioning significantly longer than other like soluble kind of solutions. Right?
Exactly.
Okay.
Yeah, it lasts for 1 year. It doesn't require electricity because it's based on sunlight, but it can also work under any light source. So not just sunlight.
So just like that's any light source. Interesting. So you're an R&D. You've won the Startup Fest prize. You're on all the stages pitching for all the things. You've got the technology, it works, but now you have to productize the technology. What do you need to do to turn this into a product other than carry it around with you everywhere you go?
Yeah, especially if it's in an environment where you're looking to have this like coated to the containers of the water, which is like a little different than like, again, me just throwing it in here and having to go at it, right?
Yes, so actually a lot of things happen since Startup Fest.
Okay.
So
It's like a whole 3 months ago or something.
Because you're moving real fast.
yeah, so we were able to apply for all the patents for eight of the materials.
Oh, wow.
And we were able to officially sign 3 paid pilots.
Yeah.
So we have a pilot with a filtration company in the US for which we are coating with this powder 110,000 filtration units.
Right.
And then we have 2 other pilots. One is in Kenya, where we are coating tubes in water kiosks for communities. So water kiosk is in communities where people don't have access to clean tap water. They usually go to a kiosk where they purchase the water, and these kiosks are not able to eliminate, let's say, cholera when there are cholera outbreaks. So we ensure that the cholera outbreaks don't happen. And so we work with them and we replace chlorine with our material.
Cool.
So that's in...
So are you licensing the technology, or you're actually coding?
We are actually coating,
Right.
yes.
I see. So you're sending stuff to them, and they're sending eventually stuff
Yeah.
back to you, and you're sending them new stuff.
Is it your intention to be like a direct seller of this, or because like obviously you're talking about like the personal considerations of people not having access to daily clean water, but it seems like when you're looking to scale this, you're going for what's the broadest container of water we can go to like decontaminize this or clean it? Is that a function of like the science behind it and the necessity of it, or like you think that's the best way to productize, sell, get it to market, like have customers? Like where are you at in that consideration?
Yeah, so with these paid pilots, it's more of a use case. The pilots are valued at $2.5 million. So we want to finalize these 3 pilots. And then, so I mentioned the water kiosk. We also have a 3rd pilot, which is in South Africa, where we're actually cleaning a river. So maybe you heard during Paris Olympics, there was so much E. coli in water.
Yes.
Even though they spent like...
For very specific reasons that we're not going to talk about as it relates to people in Paris and their interesting approach to the Olympics. But yes, it was a very dirty body of water.
Yeah, and even though they spent 1.5 billion euros, the Olympians were still getting sick. So we realized that our materials can eliminate E. coli as well. So what we are doing in South Africa, we are doing a test case on the cleaning a river, where we have a huge mesh which is coated in our material. We place it on the river, and then we purify the water coming through. So in South Africa, we have a pilot for 4 months.
So it's moving water. It's not stagnant water.
Yeah.
And do you have like multiple mesh layers to catch it all?
It's a huge mesh,
It's like,
around 25 meters squared.
Wow. Okay.
Yeah.
That's crazy.
So how effective is the material then if you're like you can have it coated, so like you can like a body of water can sit within the container, and then in 30 minutes you're good. But it's also powerful enough that if moving water is going through a filtration system, and it also purify that?
Yeah, because the river, our aim is not to make it drinking water. We just want to get rid of the E. coli.
Gotcha.
Oh, I see. That's
Okay. Interesting. And then are you, after these trials are done, going to evaluate like what was most effective, easiest to sell through, interest? Like, are you kind of still in like the R&D phase for like your go-to-market too? Or do you have a personal preference? Like when you set about this motivation to like have this thing and you're carrying around a vial in your pocket as you're pitching to people saying, I've got this really interesting powder.
How does that work on airplanes, by the way?
Yeah. When you're thinking about like maybe 2-5 years from now, and this is truly a market, what does it look like for the average person? What does that product look like to you?
Yeah, so ideally we want to be able to use these tests and scale each of them. We want to work with filtration companies. So the one in the US is a camping filters. So it's also a big problem in developed world. So we want to go with the filters, but also we want to go on much larger scale, which is water treatment facilities, which are cleaning millions of liters of water every single day. But that's in the future. We realized that we've been looking pretty far to Kenya and South Africa. What we understand that after we pitched our technology, we've gotten some connections with indigenous leaders in Canada who told us that over 89 First Nations still don't have access to safe water. And there's a huge problem with E. coli. And they basically, the problem is a household issue. So people, we need a solution per household. So we realized that we would need a special filtration system for a specific household.
Because they have like well water or something like that, or how they get
because they are so spread it away from each other.
Okay.
So we are talking to some indigenous leaders in Canada to see how we can use our solution to solve the problem also in Canada.
Do you need to, is this like we're going to talk about the IP things for a second here, because that's going to be super interesting. But I'll ask the boring question.
Oh, you can ask the IP question.
All right, cool.
I'll ask
I'll ask the slightly more interesting IP question. So you are not from Canada. You came here to build a thing. The problem that we have as a country typically is taking smart people who make cool shit and commercializing that. We're really smart, but we have an inability to commercialize those things. That's one of Canada's weak links.
Canada's bad with money.
We're okay with money. We just don't like spending it. So you have done the impossible, or the thing that we want to do a lot of, which is smart people making useful stuff and then actually taking it to market. What have you found, especially after having lived in a couple different places, what is it like taking IP to market in Canada? How is it hard, easy? Like, I know you've got lots of scholarships and grants and stuff along the way, but what do you feel that there's a culture of willingness to adopt? Or like you said, hey, I gotta go to Africa to then address the indigenous folks in Canada. That seems like a very long way around to.
Yeah, well, we, our entire team decided that we were not gonna just sit here and see what opportunity comes, but we all went to Kenya together.
Sure.
We all went to South Africa together to make the connections, and I think that was a game changer for us this summer, that we actually saw it with our own eyes and we made the partnerships ourselves in those countries. And I think that the indigenous population is going to be a little bit longer run,
Right.
because there are several issues that come with that.
Sure.
But we also need to respect their culture. That we usually have to wait for them to come to us themselves first. So we don't just reach out to them, but they have to reach out to us.
Fair enough. I guess just going back to the original part of the question, I don't know why I asked this 8-part question in one question, but going back to the creating IP and commercializing it, that's something that we struggle with as a country. What do you attribute your success to? Is it the ecosystem you're in? Is it that you speak business and you speak tech, or you speak IP, and you have that rare skill set where you can do both? Obviously, you have co-founders. I get it. But why do you think you're successful compared to, like, is there something about Canada that made it easier for you? Or is it just like, no?
We're just kind of shocked at how much you've been able to accomplish in a short period of time compared to some of the other companies that we speak to.
We're trying to see, like, why? What did you do?
Like, by way of comparison, I was, we were both at All In a couple weeks ago, the AI conference in Montreal. And I'm speaking with a variety of, like, AI adjacent companies. And they're like, government doesn't help with procurement. There's not enough funding to compete here, and we don't get support. Like, we have to sell internationally, and like the government support that we do get stops at the border. They get us to another country, and they don't help us close there. And you guys are just bopping around, winning awards. Like, you've got you had received I think you've got $180,000 in non-dilutive funding to date. I don't think that counts any of the potential Startup Fest winnings. You got a $100,000 grant from the 776 Fellowship, which is a 2-year program for youth entrepreneurs run by Alexis Ohanian, who's one of the co-founders of Reddit. Interesting stuff. You have 3 trials already underway in different geographies in the world, and it doesn't seem like you guys are cold-hearted business analysis strategy. You're just following your hearts and going to different parts of the world and making that happen. Why has it been so easy? I guess we're just old and cynical, but it's novel that it's been like that for you.
Well, it just maybe it looks easy, but there was just so many failures. Like last year, we would be probably told no every single time we asked for something, and now we've been told yes for quite a while.
What was the change? Why did they start saying yes?
I think something that was a game changer for us was the 776 Climate Fellowship. We got it in May last year, and being supported by Alexis, I've met him already 4 times, so he always gives us some advice. But the 776 Fellowship has connected us to so many opportunities that we would never be connected to. I was just last week at the Goals House at the UN, General Assembly, and I met Matt Damon, the actor, and he's the founder of water.org. So he gave me his contact card, and because of Alexis and because of all the connections, because we are supported through them, we got access to so many people that we would not be able to access.
You kind of sold through to the peer network in the international community that cares about this alongside, right? So this is like not the standard funnel for like most scaling Canadian businesses. You've tapped into like social concerns globally, and that seems to be an accelerant for you guys?
I feel like many celebrities and many very important people are now talking more about climate problems. And water is just such a huge problem, because if we don't have water, we cannot really do anything. And I think many people are realizing this. It's also a big problem for women that spend so many hours, over 200 million hours every single day, searching for water around the globe. So I think that's the personal story and my personal passion, but also like how big the problem is, and that's actually expected to get worse over the years, not better. So
Okay. When you were talking before, I'm going to ask the boring question now, which might be as interesting as the one that you just answered, because it kind of ties into this. Because you're talking about maybe the grant money, but more like the connection to 776 and Alexis. And then like, yeah, if you can call Matt Damon and be like, hey, Matt, help me out. That's pretty cool.
His number is 555 on the business card. I don't know.
Yeah, it's 555 Matt Damon.
Yeah, exactly. I don't know if you can trust it.
Jeez, that broke me. Okay, let's bring it back. But like, obviously, this is like, we talk to a lot of like, I'm going to put you broadly in like life sciences as a sector. We initially got connected. You came in through like our U of T office hours, and I was like, who is this person? We need to write about them immediately. But like, speaking to a lot of companies in that set with like similar intentions, they're like, well, the science is hard. Getting access in the testing is hard, and then most of the work that these people do, like in some ways, like a real physical, tangible product, and you're doing that for like large bodies of water or flowing rivers. It's cool that you've got a couple of $1 million in pilot programs, but this seems like it's going to be very, very capital intensive to scale. Are you expecting to raise funding? Do you feel like you can bootstrap this with additional, like when does this go from, and I'm assuming it's probably tied to that pilot phase, from like, okay, we've got this, to now like we have to actually scale and ramp production. Like, are you guys you've got one vial, are you just manufacturing like a whole bunch of powder somewhere in the GTA that you're just like waiting to deploy? Do you do the production locally? Like, as a global problem, you're gonna have like the same global logistical considerations. How are you gonna finance that?
Yeah, so
I tried to make the money question as interesting as I possibly could. I think I did a pretty okay job, but it does, like for people, everybody wants this to be a functional solution, but you also have to like distribute it around the globe. So how are you gonna pay for that?
We are currently raising money. Actually, we want to raise money before the end of the year. It's over $1 million. We've been getting a lot of traction when it comes to investment, but still we are hoping to close the round in the next 1.5 months. That's going to help us with the manufacturing. But actually, when we coat this on a filter, the thickness of the coating is just 0.5 millimeters. So it's very, very thin. And that's why we don't need much powder. So at this stage, we are still able to manufacture this all in a lab. But when we have a higher demand, we will be going after factories.
Gotcha. And then you had mentioned before that like you'd have patents or discovered like 8 different materials. Are those just like some of those additional discoveries that you had just made through the quantum chemistry? Are they all going into the product? Are they like you add a new material for each other microorganism you're trying to kill? Like, are those all part of the product? Is there going to be like a Xatoms Plus
for
premium?
chocolate milk? For chocolate milk.
We're just like where it does taste like chicken. Like, does it all go into that, or are you just partially collecting patents as part of this discovery process, and some of them are towards the product?
All of them are towards the product, but different types of products. Depends on the geographical location. Some geographical locations are having issue with E. coli, some of them with cholera.
Okay.
Some geographical locations have an issue with chemical pollutants such as DDT, still up to date.
Why wouldn't you just smush it all into one and or can you do that?
Well, we first analyzed the sample of the water. And
No, I
then
mean, like, why wouldn't you put the DDT, E. coli, virus coating? It does it all. Like, is there a
you
reason
have like
you
the
can't do
ultra
that?
model that just covers everything?
Is
or
that
do
impossible?
those react with each
we
other?
need to understand what's the exact dosage on those. I have to analyze the water we want to purify. And then we see, okay, we have to add 60% of this material because that's the amount of E. coli there is, and that's the biggest problem. And we need to add the powder, which is more effective in purifying E. coli.
So up until this point, I definitely, and I'm willing to admit this to our audience, just been seeing this as like the much better version of OxyClean, but it sounds like you have to, like, per body of water, do a level of calibration to get the chemistry right. How does $1 million fuel that? Like, that's a couple of additional staff. That's like, I'm assuming that's not going into production. Like, what are you going to use to spend that money on? How does it get you to
And
the
will you
next
need to
step?
raise again in January, I guess is the question.
Yeah, totally, right?
That's going to give us a runway for over 12 months. And we are already working with local partners in Kenya and South Africa that are going to be helping us with that. They've been already trained and they understand the technology. We are working with universities as well in South Africa because South Africa has a huge problem with water. Yeah. And we've been getting a lot of support from NGOs and these water organizations all over the world. So we don't have to spend much time on the staff. I feel like people are more than willing to help us, the ones who are associated with these big organizations.
And there's enough like grant or pilot money out there for you guys to continue to string along the refinement process that you're not like going to be out of money anytime soon?
We are going to raise another round next fall, and that's going to be a bigger round. But
is the round, the $1 million, like angels, or is this like venture, like
it's a VC
institutional capital?
Is it Matt Damon?
Well, we will see.
Matt Damon. Okay. Yeah, exactly.
Matt,
I didn't know you had fun.
Okay. Are the pilots profitable for you, or they just break even to cover the cost of the learning?
It's around $1 million profit. Yes.
Oh, okay.
Because we make a 70% margin on our sales.
Jesus. Okay.
So that's why I was going to say, why do VCs, normally when you're early and you're proving stuff out, they're like, well, wait, you take the risk, we'll wait. But the fact that you've at least made money on it.
70%
like
margin on clean water sounds pretty optimal.
It's like Coca-Cola amounts of margin. Anyway.
But, like in Canada, that's probably what the VCs wait for. But in the US, if they hear something exciting, they don't really want to see much traction. They just invest.
Are you navigating like a Canada versus global interest? Because you're already at like Alexis, Matt Damon level, and we know part of the reason why we're talking about like Canadian companies having a commercialization problem is just like a lack of capital here, or like the systems, or even like some of the companies that we've written about, like lab facilities in Canada to do this work, so they have to go international, but then they might not be able to get IRAP funding because they're like their labs somewhere in Europe, stuff like that. Like now that are you looking at this from a global financing option? You're not limited to Canadian investors. Are you interested in Canadian capital, or are you just going to take it for wherever the best fit is?
I have a $10 bill,
Yeah.
US in my pocket. If
we will purchase that vial.
Yeah, exactly.
Right now.
Well, thank you. What are you going to use it for?
I don't know. Let's see what happens.
We are definitely going to like.
What's it calibrated for? I'll use it for that.
Actually, that's a better question. This is why Rob is the more technical person. I was like, who can we give this to see what happens? I go to the pure scientific method. I just want to like do something and observe. Rob was a little bit more thoughtful with it. But that was a very interesting question that you used to distract from my question.
Mm-hmm.
In terms of, because again, you have a global story, and you came here through very unique circumstances, and then you have been jet setting around the world trying to target communities where this is a real issue. Mm-hmm. We are a Canadian tech podcast, so obviously we have a bias, but did you receive interest or support from the ecosystem initially? Are you getting it now that they're paying attention? Or like, are you interested in pursuing that, or are you just like, in
find
the Matt
the best
Damon shopper?
price of capital and get that capital irrespective of where it comes from, kind of thing?
We are going initially after Canadian VCs.
Oh yeah?
Mm-hmm.
Why? Sorry, I just...
No, it's really interesting. Yeah.
Well, when we won at Startup Fest, we got so much support from Firehood, especially. And so they've been introducing us to more and more VCs. And that was our initial goal, to go after Canadian VCs first.
But what does that matter?
Well, maybe just know. I think some of the commitment from the Startup Fest awards that you had won, which we will link to in the show notes, were as tied to like, if you accept this matching investment, right? So like that wasn't just you didn't just get an oversized check. It's like an oversized term sheet that you've got to follow through on, right? So I'm assuming there's some interest in you like capturing the returns from being on that stage. Is that correct?
Yeah.
Okay.
I'm stuck on oversized term sheet, to be honest with you. That's got me. It's like signed with a big pen.
Yeah, this is the biggest safe I've ever seen. Okay, I think given our interest in this, we should just set some time to come back when you are closing those term sheets, when the pilot projects are done. You are pitching here, hopefully for a potential other committed capital to receive.
After this, yeah.
I really appreciate you coming on to talk to us about this, explaining quantum chemistry in a way that I feel like I kind of feel less stupid about it. But then also just, I think the way that you've articulated your approach to like going where your heart is and solving problems, because it's, we are impressed by the speed and very excited to see what happens next. Totally. So we'd love to have you back and have you tell us a lot of Matt Damon stories, please.
Yeah,
you won't even record it. Just we'll turn off the microphones.
Yeah,
then we'll repeat it.
Well, I said that we are going initially after the Canadian VCs, but for our technology, we've been getting a lot of support through something called Compute for Climate Fellowship. So it's there's a Forbes article written about Xatoms on this. So last year, AWS and UNESCO made an open call that they will select 4 companies from all over the world and help them fund their R&D. And they were specifically looking for quantum companies. So we were selected for this Quantum Compute for Climate Fellowship, and we've gotten our R&D fully funded by AWS and UNESCO. That's amazing. We also work with the head of climate tech at AWS, like the global head.
Make sure your credits don't run out at the end of the year.
Yeah, so
that would really suck.
That's why we get a lot of support from the US,
Right.
and that was like hundreds of thousands of dollars on the technology side. That was why we were able to build our technology as well. And now we are going after some Canadian VCs initially, because we really want to be able to meet the people on a regular basis, and we are based in Toronto, so it would be nice if we can meet them in person. And but we are also looking for US investors at the same time.
Okay, awesome. When that shakes out, please come back, let us know. Don't talk to Forbes; those guys suck. I hope this was a good first podcast experience.
It was very nice. Yeah,
We'd love to have you back on.
Thank you so much.
Thank you.
Bye.